How are we doing, guys? So today starts chapter 10, and 10 is all about analyzing data and finding probabilities. So we're going to be looking at different graphs and charts and all these sorts of things and taking numbers and putting them into those charts and formulating data and then looking at it, analyzing it, and making observations about different things we're seeing, essentially. So starting off, we're starting with 10.1, organizing and displaying data. So for this, we're just going to be looking at charts like this first one says, looking at this chart right here, which shark lived longer than any other shark? So if we're looking at, these are different types of sharks right here. And if this is the years, it appears that right here, the whale shark lived longer than any other. And it said about how long did the basking shark live? So you look at basking shark. See right here. So if we look here, notice, so here's 40. It's broken up into 5 increments. So that means each one of those tick marks is 2. So based on that reasoning, this would say it was at 32. So it would be 32, 34, 36, 38, 40. So how long did the basking shark live? 32 years. There we go. Okay, which shark lived about 1/3 as long as the dusky shark. So here's the dusky shark, lived 30 years. Well, 1/3 of 30 is 10. We see that the hound shark lived that long. And there's our first example of analyzing data. All right, next one. It says reading and interpreting double line graphs. So it says, in what month was the cost of diesel fuel and regular unleaded the same? So looking at this, that would mean where the data points matched up perfectly. So like notice here, cost of regular unleaded was slightly ahead of diesel, was slightly higher than diesel. Here, unleaded is still higher than diesel. But notice right here, they are the same. And if we look, that occurs right here. Well, this is January, February, that would be March. So at March, they are the same. For how many months was the cost of diesel fuel more than the regular unleaded? So where diesel was more than unleaded. So that happens here. 1, 2, 3, 4. Not here, not here. 4, not here, not here, not here, not here. And here's the same cost, not there and not there either. So it looks like for 4 months. About how much more was the cost of diesel fuel in July? So this would be June, July. So we're looking here. Oops. I can't draw. There we go. So right here, it says about how much more was the cost of diesel fuel in July than in December. Now these aren't gonna be perfect. It's not like we have every single cent accounted for on here. But if I were to guess, it doesn't look like it's exactly on $3. And since the scale is it's 10 cents, I'm gonna guess that's $2.99 right here. And then this isn't quite there and it's not touching it. I'm gonna guess we're gonna say 308. And if you put you know, 3 and 10 or whatever, I mean, that's fine too. But it's roughly 10 cents. In my estimation, it's technically 9 cents. If you said 10 cents, you know, 8 cents, anything in that range is pretty reasonable based off the data we're given. All right, reading, interpreting circle graphs. All right, so number of orders, 15, 55. The table shows what types of pizzas were ordered at Vinny's restaurant one weekend. Use the data to make a circle graph, then tell why a circle graph is appropriate for this data set. All right. So if I'm making a circle here, I'm going to start with this line. Start with that in the middle. Now, what we basically need to find here are percentages. So first of all, I need to know how many total orders were made. So I add up 15 plus 55 plus 30 plus 30 plus 70. And I get a total of 200 orders. When I add all those up, I get 200 total orders. Now, we need to find the percentage. So if I have 200 orders, what is 15 divided by 200? 0.075. What's 55 divided by 200? 0.275. 30 divided by 200, 0.15. And this will be the same then. And 70 divided by 200, it's going to be 0.35. Okay. So essentially what we need to do is turn this information into a chart. So how many degrees are in a circle? Degrees in a circle are 360 degrees. That means that if I take 360, or take this number times 360, that tells me what percent of 360 degrees this is. So I take 360 times 0.075, and I get 27. So in other words, this should incorporate 27 degrees. So I'm not going to get a protractor out, but if I know that this is 90, and then this is 45, well, that's 60, and that's 30. So it's roughly this. So I will stick with that. Oops. It's not going to be perfect, but it'll be close. So that will represent extra cheese. Oops, I spelled the Z. All right, that's extra cheese. Now we're going to do the same thing here. Take this times 360. 0.275 times 360 is 99 degrees. So 100 degrees. I'm going to say if that's 0.275, that's, you know, a little over, you know, 25% would obviously be a quarter. 99 degrees. I'm going to go, if this is, oops. Again, if I'm making a straight line, oops, from here through here, then that would be 90. So 99 is going to be just a little bit more than that. So we're going to call it right there. Again, not an exact science here, but it's going to be close. That's pepperoni. All right. Then it says 15. So I'm going to take 0.15 times 360. And that's 54 degrees. So again, if this is, if that's a roughly a 90-degree angle, 54, well, then that makes this 45. So 54 is going to be just a little bit more than that. So somewhere in here. Again, not an exact science, but we're going to get close. So that's veggie. And then this, when I do that, gets me the same thing, still 54 degrees. That was 54 degrees. This is 99 degrees. And I believe this was 27 degrees. Okay. So I'm going to make the same angle roughly on that one. So something like that. Look close. And then it says 0.35. So 0.35 times 360 is 126. Times 360 is 126. So 126 degrees. Again, right here. That's roughly 90. It's going to be more than that. So yeah, it might be a little small, and maybe this should maybe be a little bit bigger, but it's pretty close. And that's plain. The biggest thing here is that this should be the biggest one, which looking at mine, my pepperoni might be a little big. Maybe I shrink that down just a little. Which means I need to shrink down veggie and meat just a little. Again, if I had a protractor, I could do this perfectly. But you know what? That's going to be pretty close to what I'm looking at. And then it asks, why a circle graph is appropriate for this data. Well, if we have all these total orders here, it's really nice to be able to just look at one chart and see, the majority, the biggest chunk was plain. And then pepperoni was second. These two were equal. And then we can look right away and see, extra cheese, not a whole lot of extra cheese was ordered. Just by looking right at this graph, we can see that right away what pizzas were ordered most frequently and which ones were ordered least frequently. That's what makes this a great use for a pie chart. So that's 10.1. Let me know if you guys have any questions about any of that. Thanks.